I'm Anil Kumar. Welcome to my series on linear systems. Let me thank all the viewers and subscribers for watching my videos and posting excellent questions. This question comes from one of our subscribers, and I hope the solution of this will help many others. We'll actually use the Gaussian method of elimination to solve system of linear equations in this particular example. The question here is, the carbohydrate, fat and protein content in grams of 1 gram of milk, meat and vegetables is given in the table. Find the amount of each food necessary for a meal of 95.2 grams of carbohydrates, 89.6 grams of fat and 137.2 grams of protein. So we are given that as far as the carbohydrates are concerned, they are 0.1 in milk, 0 in meat and 0.6 in vegetable. For fat it is 0.2 in milk, 0.3 in meat, 0.2 in milk, 0 in vegetables, and protein 0.1 in milk, 0.5 in meat and 0.1 in vegetables when we are taking each 1 gram, right? So 1 gram of milk, 1 gram of meat and 1 gram of vegetable, correct? Now, since we need to find a combination which will give us 95.2 grams of carbohydrates. So basically, let's look into extend this table and see how much total we want, right? So the total we want is 95.2 for carbohydrates, 89.6 as far as fats are concerned, and 137.2 grams of protein. That is what we need, right? So we know in 1 gram each, we have that content. Now how much do we consume of each kind so that we finally get that much of content? That is what we are interested in. So let the values be x, y and z, right? So that will give us the equation to work with, correct? So if you're writing linear systems of equation and solving using that, you could also do that, right? Method will be kind of parallel. So let me share with you the linear equations which will be defined from the data given. So if I take x grams of carbohydrate, I'll write this as 0.1x and then this is 0, but I'll use 0 here and it acts like a placeholder for me, and then I'll write 0.6 of z and the total should be 95.2. Make sense? So like this I can make 3 equations. Second equation will be 0.2x plus 0.3y plus 0z is equal to 89.6, and the last one in this will be 0.1 x plus 0.5 y plus 0.1 z equals to 137.2. So that becomes a linear system for us, correct? So I'll say this is our linear system. So we have standard ways of solving using linear systems. You can actually solve using that, no problems. But these are the equations to solve. 3 equations, 3 variables. You can always simplify this and get the answer. Now, I'm going to describe you the method of matrix. So what we do here is that we use augmented matrix. So it looks something like this. Let me just make one here. So we'll squeeze in all this data here. So we don't write x, y, z. It is assumed that x is along column 1, y along column 2, z is along column 3. So it's exactly replication of the same table. So we just put it in a tabular form, right? So we get 0.6 as you can see, 0.2, 0.3 and 0 here, 0.1, 0.5 and 0.1. So that becomes our matrix. Now we are given that this should be equal to all that. So for that we put a bar here and write these things on the right side. So we get 95.2, 89.6, and 137.2, and then we close. So this is called the augmented matrix, where we have taken the coefficients, right? So we have actually translated these coefficients into this form. You get the idea. Perfect. Now, the next step here is, as we do in elimination, we have to somehow eliminate and get 0 in this position and 0 in that position. That's what you'll do here also. So if this is equation 1, 2, and 3, you will do equation 3 minus equation 1 to get 0 here, right? Same thing we do here. We'll say, well, in the third row, these are called rows, and those are the columns. We say in the third row, what we are going to do is we'll do row 3 minus row 1. So in that case, I'll get a 0 here. And to get 0 here, I'll do row 2 minus 2 times row 1. Correct? So 0.1 times 2 will be 0.2. So when I take it out, it will be 0. Okay. So with that, let's begin. First row remains unchanged. 0.1, 0, 0.6. Right? So let me add this side also. We get 95.2. So first row remains unchanged. Second row. So we'll perform the operation. That is to say, from these numbers, we'll take away twice of row 1. So that gives me 0 in the first one. This remains as 0.3. Taking away 0 makes no difference. And here, twice 0.6 means 1.2 with a negative sign. So we get negative 1.2. Is that clear? Let's use calculator for this part. So from 89.6, I have to take away 2 times 95.2. I get negative 100.2. 100.8. Okay. So that's what I get, right? Now, we'll do this operation. So first one is 0. That is what our objective was. Now here, taken away leaves us with 0.5. And here, it gives me minus 0.5. Correct? 0.1 minus 0.6. And here, let's use calculator again. Can't afford to do these mistakes, right? 137.2 minus 95.2 gives us 42. Okay. Now we want to make this 0, right? Do you see how we are moving along? First, we made these 2 zeros, correct? And now we want that position to turn to 0. How can I do that part? So to get this 0, what should I do? I will actually do 3 times this row. So I'll do 3 times R3, right? And from this, I will take away 5 times R2, correct? Then I can get 0, right? So this operation I'm going to apply now in this particular matrix to get my result. Do you see that? So let's do this. So when we do this, I'm going to write results here. So I'll just copy the first 2 rows, which is 0.1, 0, 0.6, and here we get 0, 0.3, minus 1.2. Okay, so this is 95.2, this is minus 100.8. Okay, now this is 0, 0 minus 0 will be 0. Let's use calculator. We have to do 3 times this and take away 5 times that. Well, that should be 0. That is the purpose. Now, the last one. 3 times minus 0.5, right? So, I'll do 3 times within brackets minus 0.5. And from there, I have to take away 5 times within brackets minus 1.2, right? So, what do I get? I get 9 over 2, which is 4.5. So I'll write 4.5 here. Right? So I get 4.5 here. Now we'll calculate the last value, which is, again, let's do 3 times 42, take away 5 times within brackets minus 100.8. And that gives me 630. So this is 630. 630. So we get a matrix from where actually we can read these solutions, right? So that gives us equations. If you look into the last equation, which is what? This is as good as saying that 4.5 of z is equal to 630. Is that clear? 4.5 of z is 630. So that means the value of z is equal to 630 divided by 4.5. Correct? And that is how much? Let's figure it out. So we get 630 divided by 4.5, and that gives you 140. Do you see that part? So we get the value of z as 140, right? So we solved one equation. Now the second one. In the second one, we have 0.3, and that is y value, minus 1.2. This is z value, right? So I'll just, because we have very less space here, I'll substitute 140 for z is equal to minus 100.8. Correct? So from here, I can find what y is, correct? So that gives you the y value. So y is how much? I'm going to add this to the other side. So I have 1.2 times 140, and then there's already minus 100.8, and I'm going to divide this by the coefficient of y, which is 0.3. Is that clear? So to get the answer, let's get it. So we get 1.2 times 140, and then from there we'll take away 100.8, and then we are going to divide this by 0.3. We get 224. Clear? So we get this answer as 224. Now we know these two values, we need to find the x value. Okay, less space. So let me squeeze this also in. We'll use another ink. So what we have here is 0.1x, that is 0, okay, plus 0.6 times z value, which is 140, correct? Equals to 95.2. So from here I can get the x value. So let me use this space to get the x value. So the x value is, so I'm just jumping all this to this place. 95.2 take away 0.6 times 140 divided by 0.1. Clear? So what we get is 95.2 take away 0.6 times 140 and divide this by 0.1, so we get 112. So we get a value which is equal to 112. Do you see that? So we actually found all the three x, y, and z values. So for us, the milk was how much? 112, right? So let's write all our answers in this particular table itself. So what we get here is milk, which was x for us, right? That is equal to 112 grams, right? And as far as meat is concerned, which was y for us, was equal to, in this color, 224, right? 224. And then veggies, which was z for us, 140. All are in grams. Does make sense to you? So that is how you could actually solve this. So normally I would have taken 2 pages to solve, but now I think it makes better sense here. Everything is before you. So the idea here is, from the given information, we could actually write a linear system. We could solve this linear system in the normal method. Efficient way of doing it is in the form of a matrix. We actually just wrote everything here in this fashion. So matrix is a name we are just giving just to help our operations. However, we are doing the same operations. So first operation which we did was, we did second equation, take away twice the first equation. So we got our equation. So this is written with the augmented matrix where x, y, z have been dropped and we are only working with numbers. It makes sense, right? Basically, while solving a linear system, you're also working just with numbers. Then, the third row, we wanted a 0 here, so we took away the first row and got a 0. Once we got these two zeros, we found the way to find the third 0, and then it was simple. Z equals to this, right? So times, and this is in x and y, that is x, y, z. Once you find z, you can find y and then x. So that is how we found all our solutions. This was z, this is x, this is y, and that is x, correct? So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.